Thank you very much. First, thanks, Nick, and thanks, Python, for this opportunity. So the, the session today is about some new libraries in Python. But before we talk about the library, I think that it's like the best time for new libraries, and there is like a reason for that. Yeah, so I work at Microsoft. This talk is not about Microsoft. You would notice that. I'm civil engineer. I start like with Excel. I used a bit of Pandas. So I have like a different perspective than a diehard Python programmer. So I think you know like why it's the best time really for those new engines. If initially, for example, if you want to read data from, let's say, from data warehouse, in the early days, everything is tied together. So like the storage is tied to compute in one box. And if you want to read the data, you need to pay for the compute, something like Oracle or SQL or whatever. So that was like the early days. Then in the early 2010, BigQuery or Snowflake, everyone say we did it first, so I don't know. Let's say both. They decoupled the compute from storage. It means you can shut down your compute and you can have your data in something like S3. So that was nice, but the trick with the Cloud Data Warehouse is that the storage format is tied to the server. So the data itself is still proprietary. Like you cannot just use arbitrary engine just to read that data. Then it's around like 2017, something started, call it that data lake or like marketing term lakehouse, and the idea is that the table format itself is open. It means anyone can read it. For me personally, I couldn't stand the lakehouse because the reality is, although in theory any engine can read it, the reality is it mainly works with Spark, and you need Java-based system. So for me, it doesn't make any sense. It's like, for me, nothing really changed because you just moved from Cloud Data Warehouse with like proprietary engines to a new system where it works only with one engine. And for me, like I use Python, so I had like some strong opinion about this stuff. And then I would argue like now these days, we have something like, by the way, the native lakehouse is not like a real time, I just make it up. And the idea is that these days, all the readers are more or less equal. So even if you don't need to use Java. And for me, that's awesome because I don't use Java. So, and that open, no, there is nothing wrong with Java. Just to be very clear. The reason actually I maybe have a strong opinion about Java is like I tried once to install it and I spent one day and I couldn't figure out. It's my problem, but yeah. Anyway, let's try to be politically correct. So the good thing is these days, it doesn't matter. You can use any engine and they can read those table format. So you can use Torino, which is Java-based, DuckDB, Spark, Flink, Snowflake, Fabric, whatever, and they all works. And you may take this for granted, but 2 years ago, it wasn't the case. This is just an example. By the way, this might probably, that's the only mention of Microsoft. This is just an example of a lakehouse. And lakehouse is not specific to one vendor, to be very clear. There are at least like 3. So Microsoft have one, Snowflake, they have one, Databricks, S3, and Google Cloud. And the idea is that, as you can see here, the data is not tied to a specific engine. So you can use any engine you want. And the main two-table format, I don't know if you guys are familiar with, like there is like Iceberg and Delta. And this is like human nature. Like before, someone made the joke, he said like we went from proprietary system to 3 open source system. So like we have 3 different standards, and I think that's something about human nature. Like you will have always more standards. And I can tell you that there is some technical difference, and the reality is not true. It's like two people build something independently, and they try to do the same thing. There is some very interesting market dynamic, like which format it's going to adapt. I would say probably the market is going for Iceberg, but the thing is, the difference is only in the metadata. So a way of seeing those table format, it's a glorified folder of Parquet. That's a way to see it. So the reality is there is a Parquet file, there is a folder with Parquet, and there is some JSON, and the JSON is a way just to manage this Parquet. And the reason like we need this metadata is that if you write a folder of Parquet and someone is reading, for example, he may end up reading incomplete data. But with those open table format, it's only when you finish writing and you make a commit. So another person reading, he will read like correct data. So they fix, and all this is like some very basic functionality. They got it from database. So like there is nothing particularly new. Like we had this since the 70s. So the main difference is only the way the metadata is organized. And hopefully in a couple of years, like one solution is, there is two format, it's fine. Then when we'll show you the data and we give you the two format. So it doesn't matter if you have like a Delta reader, you will read. If you have an Iceberg reader, you will read it. OK, now maybe this is the core of the presentation. Because we have open table format, is that those new engine, like they have an opportunity to exist. So Spark is always like the elephant in the room, I would say. That's the issue with Spark is that the local experience is not great. Maybe for a developer, it's fine. But for a civil engineer who used Excel and trying to install Spark, it wasn't a great experience. And Spark is designed for really big data. So if you have like smaller data, it's not that great. But the support is amazing. And like stuff like reading to Delta or their data frame API, or like everything is great. They have like their cache to object store. Is like fantastic, but just like the user experience for a laptop is not great. And then you have DuckDB. I'm a huge fan of DuckDB. That's what I use mainly. And just to pretend I'm objective, so add this the red. Their data frame API is a mess. They don't. I think it has like an identity crisis. They don't know what they want. Hopefully they improve that, but today it's all over the place. There is Polars. And Polars, Python people love it for some reason. And my issue with, like, I have no problem with Polars. The only thing is it's not a streaming engine, and I will explain streaming later. Polars people will say, you don't know how to do it, we are streaming, so that depends. And Polars don't really care about SQL. They use their own API. Then there is this, the 3.1. Those guys are new, but they are very promising. You have Daft. Daft is very good. Like I use in reading CSV, it's awesome. It's more into the AI and reading image, which is something I don't really understand. But the main developer is cool. There is this new guy, Lake Sail. I like it very much because they're not trying to create new engine. They took existing engine and they create their own parser, and they try to make up a new product. So that's awesome. CHTP, it's based on, I don't know if anyone familiar with ClickHouse. So ClickHouse is like extremely big, like data warehouse for like all-up workload and real-time. And they saw like a lot of people talk about DuckDB and Polars, and they said, we'll have library too. It's promising, but it's early days. And you have Datafusion. Datafusion probably you are using it, but you don't know because it's not really for end user, but it's used by other engines. So for example, Lakesell used Datafusion behind the scene. And I think it's interesting because there is like a lot of different companies working on Datafusion. So for example, Apple used Datafusion for some reason. Probably you're asking, where is Pandas? Yeah, I use Pandas a lot, but the thing with Pandas is Pandas like need to keep backward compatibility, so they can't really do some massive innovation. And Pandas is pure in memory, and in the use case I'm doing, I'm processing 150 gigabytes of Pandas will not do it. The thing is, you can be smart and say Panda is not great. The reality is last month it was downloaded 500 million times. So, and DuckDB was downloaded 22 million. So I think people like Pandas. So I put this before on Twitter, and I like because Python, they're very opinionated, and this is one of the guys who like pollers. And I like his approach. He told me like, he don't care. He don't use SQL. So all my talk doesn't make any sense for him. Like he's happy with API. That's why it's not really objective. It's just my personal views. There is another thing that it's awesome. Something called Arrow. It's created by the same guy who made the Pandas. And basically, it's a standardized way to exchange data between Python programs. This one is awesome. Even Spark adopted Arrow. It took them years, but I think they were forced. Now let's talk a bit about analytical queries. So here I will just use example. This is a typical, it's called TPCH. Legally, you cannot say, it looks like TPCH, just to be very clear. The reason I liked is it doesn't mean match. Like if your workload is not close to this, then who cares? But the reality I liked because I'm more interested into the trend than the exact performance. So I tested just for fun. Usually people, when they show you numbers of tests, they show you a server with 1 terabyte or. So for me, let's try something different. Let's use like the smallest compute and see how those engine works. And the reason it's interesting to test into smaller compute, because there are some stuff where basically if you throw a lot of hardware, everything is cool, like everything will work. It's only with small RAM when you start seeing the issues. And DuckDB is just freaking amazing. It's like here, every SF means 6 million. So 167 means 1 billion. And it's scaled nearly linearly till 1 billion and starting from 600,000 rows. So for me, that's amazing. By the way, there are other engines that can do that, but they are proprietary. I'm not naming names, but here it's open source, so that's awesome. The other engines, they're doing well. For example, for Lakesell, the issue that it got the join order wrong, so it starts. But overall, like it's, yeah, they're great, but compared to DuckDB, it's, yes, this one I liked a lot because this one you can see the history. So I'm starting this from September last year, and I've done the test just a couple of days ago. And it's the same test and same hardware. And the performance is, last year it was around like 8 minutes, and these days is like 3 minutes. And the red, like the horizontal, yes, it's horizontal. It's around 2.3. That's like the state of the art at our house. So open source are really doing well. I really like that Lakesell, because Lakesell it's like pretty new. I'm happy that it starts showing up there. The thing is, it's all about the interpretation. So someone read this, and he will say that DuckDB is maybe 3 times or 2 times faster than Lakesell. Actually, that's not true, because in this particular case, DuckDB support cache from remote storage. And these days, actually, what's happening is those engines are going so fast. Now the bottleneck is reading from remote storage. That's your biggest issue. So here, I'm not saying that DuckDB is twice faster than Datafusion. I'm just saying, and by the way, the improvement, just because when they add the cache, I'm saying here that if your data is in the cloud, you need a very good cache. Alternatively, because it's Lakehouse, even if something doesn't work, you can use a data warehouse to read it. So that's not an issue. One point here, because I've done a presentation before, and someone asked me, like, what is small data? And there is no universal definition, but let's agree on something. Like, if your data fit in memory, then everyone is happy. These days, even if your data doesn't fit in memory, those modern engines, they can spill to disk. The thing is, disk is extremely slow compared to memory, but still it works. The worst case scenario is, even if your disk is full, you can spill to remote storage. It's virtually unlimited, but it's a bad idea because it's extremely slow. Like something like S3 is very slow compared to your disk. The thing is, it's not really perfect. Those Python engines still you get out of memory. Now, about the transformation. When someone say big data, I can, for example, read and process 1 petabyte using 16 gigabytes of RAM. I probably say it's talking nonsense, but that depends on the complexity of the transformation. So you have two things, the blocking operator and the streaming operator. If you are just reading and doing something like filter, then it's fine. The data itself doesn't matter. But even if you have a small data and try to do sort, or let's say if you have 2 tables and you do cross-join, and then you are in big problem because it's become like a blocking operator. And blocking operator means I need to see all the data before doing any output. So when you say even something simple is what is small data, there is no like clear, that depends. And here, let's see if, yes, this is from Daft. And I like this. This is like awesome. It's like, actually it's nice in demo. And here you can see it's reading like nearly, actually it's reading like nearly 1 billion rows. And you see the RAM, it's 16 gigabyte. And it's like reading and writing the data in a streaming fashion. It means like it read in a batch, read a bit of data and write and so on. Something like that like cannot work with Pandas. Pandas doesn't, no. Pandas is just C file, load everything, and filter. That's not very efficient. Yeah, now about data transformation. So here I've done another test. Probably this one is more relevant. So my data is 150 gigabytes of CSV, and I tried all those engines. And then I put like different, because I'm running it in a notebook, and I can configure the number of cores. So I started from 2 till 64. And Daft and DuckDB, they works. They process 150 gigabytes with 2 core and 16 gigabytes of RAM. For me, that's like the nearest thing to magic. Something like a couple of years ago, you would have like use a distributed system. I had a whole team and saying this is big data, and now you can run it with 2 cores. And then the thing is, you notice the polars and CHTP, they work only when you have 32 cores. And the reason why, because they're not yet fully streaming engines. It means you need a lot of RAM to finish the operation. In this particular case, and by the way, I'm not trying to say bad thing about Polar. This one is not fundamental. They're just working on it. And in a couple of weeks or even months, this may look totally different. So there isn't like something fundamental that's specific to Daft, and DuckDB. And the thing is, it's all open source. And the developers, actually, they know each other. And sometimes you have the same developer doing the same work for two engines. And there is no secret. Basically, good ideas, they tend to spread. So this is just like the current situation. This is the same chart, but like using lines. And you notice something here is that you reach a point where adding more compute doesn't help you, because the bottleneck is the bandwidth from remote storage. For some reason, I like this chart very much. Like, more hardware doesn't mean you're going to get something faster. So yeah, Python is awesome. We have a lot of engine. It's very competitive, blah, blah, and all these things. But in my perspective, the worst thing about Python engine is that there is no standard API. So I tried just to export from those engine to Pandas. And you notice here how many different syntax. Like, there is no even one way to write export to Pandas. You may argue it's not a big deal, but imagine someone who never used Python before, and this kind of stuff are not great. Here is another example, doing the same transformation, using DuckDB in SQL, then using Polars in Polars API, I guess, and using Spark. The thing is, they look all similar, but they are all different. And it's a bit of pain. OK, people are aware that there is an issue, so they try to solve this problem. And there is IBIS, which was started by the same guy who made Pandas. And the same approach, different, like a lot of backend, and hopefully the same language. And they all basically generate SQL. Now it's getting ironic. So a lot of people are trying to solve the problem, but even the solution, we have three. Same guys, I don't know how to pronounce it, Narwhals, the same thing as IBIS, but the only difference, their API is inspired from Polars. And there is this guy, SQL Frame, and he's solving the same problem, but he decided to use PSpark API. I'm not trying to sound negative, but I reach a point where, like, life is too short. And just to learn, because the issue is there is no, like, fundamentally an added value in having different syntax. Like, group by or group by underscore, like, it doesn't add any value. Just do group by, like, just one, stick to one. The thing is, I think that that's like human nature. I think like human like to create their own query language, and you have to live with that. So for me, I just decide I'm just sticking to SQL. Like, so this is an example of like real life implementation, and I think I'm using pure Python and just single node, and just by as a matter of principle, like I have access to 0.5 terabyte, but just I used only 16 gigabyte of RAM for some reason. Like, I'm just trying to make a point. Like, I can't do everything using just small compute. Because for me, adding more hardware is lazy. It's just hiding the problem. Instead of creating something efficient, you just add more hardware. So here, yeah, this example is it's IMO, it's the Australian electricity market. It's a government agency, and they're doing an amazing job. Like all their data is publicly available, and it's awesome. Like, so I'm doing the typical thing, lending data and processing data, and then using BI tool to read it. Here I'm using the Python to get the data, and actually here I'm not even using 16 gigabyte because for me 16 gigabyte is too much. I'm using like a cloud function, which has like 2 gigabyte. And it works great because all it does is just, yes, 5 minutes. And although I tested all those API, I end up using just SQL. So for me, like if you're doing data, by the way, like I'm not expecting people to change their mind because someone said something. Like the change, picking the language is extremely personal, and people have extremely strong opinion. I'm just sharing my own experiences that for some reason SQL is used everywhere. For me, it's more practical, and I can switch between different engines. And yeah, thanks for listening, and yeah, thank you very much.